This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Hello everyone, I'm Felienne for Software Engineering Radio, and I'm here today with Sam Aaron. Sam wrote a PhD on domain-specific languages and now works as a postdoctoral research associate at the computer lab at the University of Cambridge. While doing that, he has designed a programming language called Sonic Pi, and that's what we're going to talk about today. So Sam, what is Sonic Pi?
Hi, so Sonic Pi is not actually a new language, it's more like a domain-specific language based on top of the Ruby programming language. And it essentially turns Ruby into a musical instrument that anybody can learn and anyone can experience the creative power of code.
So why did you create Sonic Pi? What is the problem that it solved?
So this came back a few years ago when the Raspberry Pi first came out, and it was incredibly successful, as we've all seen now, but it surprised everybody at the time. And although they were selling lots and lots of Raspberry Pis, the promise of the Raspberry Pi was it was going to have an impact in terms of how we engage children in learning to program. And part of that problem is making sure that they have affordable hardware at home, which the Raspberry Pi solved, but the other part is making sure there was interesting software to run on it that they could use to engage themselves with. And so from the early days, Scratch was on there, but there was an open question to what other piece of software could we potentially build that may potentially help children engage with programming. And the Broadcom Foundation, which is the company which designs the chips, they had a small pocket of money for a 3-month guerrilla project to see if we could have a look at this problem. And the questions were bounded around in the computer labs. Does anyone know anyone who potentially could work on this? And because I'd already been working on music software for a number of years, building something called Overtone, which is a closure front end to SuperCollider, it seemed like a natural thing to give me a shot at building something very simple that was essentially an Overtone, a live coding platform, but rather than aimed at professional programmers, it was aimed at children to see if we can lower the barrier to entry.
Maybe not all listeners are familiar with what Overtone is. Can you explain that?
Yeah, I mean, probably to understand that, you also need to understand what live coding music is, and I'm sure we can talk about that at length later. But the idea really is, in terms of these musical systems that use code as their interface. So instead of hitting sticks on drums or plinking strings with your fingers, we write code, we evaluate that code with some system, and the result, the side effect of that evaluation is some music which is produced or some modification of the music which is currently playing. And so through the definition and redefinition of code, we're able to create musical compositions and performances. Overtone allows this using the SuperCollider synthesizer, which is a really powerful open source synthesizer. But as the interface, we use the Clojure programming language, which is a Lisp which runs on the JVM, which is one of my favorite programming languages. It's a really beautiful language. And so it was interesting to me to explore how a Lisp-like language running on the JVM with all its access to libraries, which had a really emphasis on concurrency, could be an interesting platform for exploring music, performance, and composition. So that was Overtone, which was a project created originally by a chap called Jeff Rose, a close friend of mine. But a month into him starting that project, I discovered his existence and he discovered mine, and we worked together very closely since then.
But despite Clojure being your favorite programming language, Sonic Pi is built on Ruby.
Yes.
Why?
Mainly because the context with which the Sonic Pi language or environment was created dictated essentially that Clojure wasn't really a good fit. There were two main reasons for this. One was that the Sonic Pi had to run on a Raspberry Pi. And so at the time, the support for JVM was very weak, and starting a Clojure REPL took minutes, not seconds. Starting Overtone inside the Raspberry Pi took about 7 minutes to boot, probably mostly because of my inefficient programming at the time, but that wasn't really something that was feasible. But also, the environment has to pass what I would call the head teacher test. So the head teachers would often come to me in workshops I'd be delivering when they were interested and ask, why are you not using Python? And so I would need to have a very good reason why I wasn't using Python. Because Python is the language in the UK that pretty much all schools are focused on, so it's Scratch to Python. And so Ruby allowed me to answer that question very simply. Ruby is very, very, very similar to Python. The UK government uses Ruby for all of its open source projects. Twitter was originally built in Ruby, although it's not anymore. It's still, these arguments aren't really necessarily what's correct and what's not correct. It's what passes the head teacher test, because the head teacher doesn't really tend to know that much about software, but wants to be convinced that's a good reason. So Ruby allowed me to do that very effectively. And Clojure, it would be much more of a struggle to have the argument, which I feel a shame, but it is the way it is.
Sure. So how did you know how to make the language? Are you a musician yourself? Do you play any instruments?
So that's a good question. So let's unfold that. I did a little bit of music at school. I played clarinet and saxophone in a jazz band, but nothing more than that. Certainly nothing at university, nothing later in my life, so no professional music knowledge. But it's just the same as saying to any software developer, if they enter a new business domain, you don't know about the pharmaceutical industry, so how can you program in that industry if you don't have any background? Of course, you don't need a background in the industry. You need to be able to have a background in programming, and you go and learn about the programmable aspects of the industry you're working in. And then you go and work in a bank, or then you go and work in a sports company, or then you go and work in an environmental company, and you can still take the skills and transfer them, and you learn the aspects of the domain on the job. Music is no different. And so I learned about the aspects, I'm still very much learning about the structural aspects of music on the job, and as I learn that, I turn that knowledge into workable abstractions within Sonic Pi that allows me then to share that knowledge with a broader audience.
But if you work in a bank, you have a customer that can introduce you to the domain.
Yes.
Who did you have to help you?
So at the time when I started working on in the domain of music, I was working on Overtone, and it was a year in Amsterdam, 2 years in Amsterdam I was working on it, then here in Cambridge. And when I really started to apply my knowledge to learn music with fervour, it was here in Cambridge, and I met a number of people who had large amounts of musical knowledge, and I brought them over to my house for a weekend, bought lots of beers, and it was important then to try and get that knowledge from their head into my head. And so then I would then program my understanding. I'd ask them essentially, what is a scale? What is a chord? And then they would tell me, and I'd say, well, I don't know what that means. And then I would ask them to give me more and more detail until I could then codify what they said and then present them back what they said in terms of code. And once we reached an agreement, then I knew I had understood what they were talking about. So it's really the same as you program for any industry. It's really about trying to learn and understand the formal aspects of the domain, the programmable aspects, and then try and represent that in code.
Yeah, so you really use code there as a means of learning about the domain by implementing it and
Precisely, yes.
understanding it.
Precisely.
So one of the goals of Sonic Pi is to be fun for a very broad audience. That's your design goal. Can you talk a bit more about that?
Yeah, I mean, like the most important design goal, which probably doesn't sound very ambitious, but it's really important, is to be able to give people, and that's not just children, it's everybody, an initial experience of programming that doesn't scare them off. And I think that a lot of initial experiences are really quite terrifying or don't have any direct meaning to people's lives and are very off-putting in the long term. And I think that's quite damaging for a lot of people. So for me, trying to figure out how to make that initial experience friendly and not scary was pretty much the only main goal. And then beyond that, of course, the things you're describing become really important about being fun and engaging and exciting. And I think they're all for me, means of motivating and engagement. And so the question to me isn't about what aspects of programming should we teach. To me, the important question is, how do we figure out ways to engage people in programming that creates meaning in their lives, that the solution is some programming. And so they're learning to do lists because the idea of a list has value to them right now for what they want to achieve. So a good example of that is we didn't teach lists, we taught bass riffs. And so a bass riff itself is a list of notes. And to perform a bass riff, you need to teach iteration. I want to map a function over that list, or I want to, for I equals 0, beginning of the list, there's different ways of achieving that, but essentially you want some process to work over a list. So that's to make a baseline. It's not to sort a list of numbers or just to print out a list of numbers on the screen, because I don't think that's necessarily engaging to a broad audience.
Yeah, so you take a problem or a task that someone already wants to do, like making a song, and you try to express that with source code.
You show them new ways that they can do things that they couldn't do before with code. So it gives them new powers.
However, what's really different from other programming languages for children, like Scratch, for example, Scratch isn't all that fun if you're a grown-up. After a while, it's a toy, and it stops losing its appeal. But Sonic Pi is also used by adults, especially live performers that perform live coding. We will talk more about that later in the interview. So why is it important to have a language that has such a broad audience? I mean, you could make one language for kids and one language for performers, or special versions of the language, or different versions of the IDE. Why do you want a one-size-fits-all solution?
There's probably two main reasons for that I can think of right now. First of all, there's just one me building the thing. And so if there was 100 of me, then maybe we could explore multiple things you just described, multiple versions, multiple iterations. So the constraint of development time is an important thing to consider. But also, it's really important to me that to explore the idea, I mean, in my head, I see Sonic Pi like a piano, or like a violin, or like a guitar. These instruments have evolved over many hundreds of years. So it's not really a fair comparison. But they can talk about where these things can go in a few hundred years, what would be the equivalent of Sonic Pi in a few hundred years, and what would it look like? I hope it would have the similar properties of a guitar, which is anybody can walk up to a guitar, pick it up, and make some sounds. Anybody can learn how to play all of the notes on the guitar in 5 minutes, because you just need to hold your finger on a fret and pluck a note. And you move your finger up and down the fretboard, and you get different notes. And you can move across the strings, and you get different notes. So you can learn it, and the same as a piano. You can learn how to play all the notes of a piano in a very short amount of time. But to master a piano, that's a really difficult thing. But why would you master a piano? That's because there are pianists who have spent many years who can do amazing things. And so it's one thing to make something simple and easy to work with, like the piano is, but to me there's no real value in that unless there's deep motivation to aspire to something that other people are able to do. And so having the simple approach is just the starting point. Having the motivational value in seeing what you could do if you spent many years practicing and working on this. I think that's why people pick up a guitar. It's not because it's simple to pick up. It's because they've seen their favourite guitarists do amazing things on stage. And so, to me, Sonic Pi, one of the goals is to see if that kind of view of the world could be applied to software. Could it be possible that people would pick up software, not because they've been told to in school, but because there's people they respect in the world, musicians maybe, that are using similar software that they then think, well, I want to do that too.
That makes total sense, that this sort of showmanship of live performing also has the role of getting children in, but maybe also other people that aren't necessarily programmers by job, but they think, oh, that looks nice, I want to be like that person. So that high level goal of making it simple but also powerful, how does that translate into concrete goals for the language? What decisions you made in the syntax of the language or the features that help you achieve that goal?
Yeah, they are very hard constraints to meet. So with Overtone, my previous system that I was working with Jeff, we just used to think of cool ideas, and then we used to think, could we build those ideas? And if we could, we built them. And so the system expanded quite rapidly, and it's a very powerful set of features. And if people are interested in learning Clojure and already are professional programmers, then it's a really great environment to start with. But Sonic Pi, trying to reach a broader audience, is trying to lower the barrier to entry. And so if your barrier to entry is you need to have a compliant IDE like Emacs, or IntelliJ, and you need to understand functional programming, there's a lot of these barriers. And so it's not just good enough to think about, is this a cool idea? It then has to pass through the test of, could I implement the idea? Which then has to pass the test of, if I do implement this idea, does it tessellate well with other ideas? Does it fit in terms of a cohesive design? Which I think most programmers would already understand. And probably, for example, if you're designing an API, if you're going to add a new endpoint, you think, well, how does this fit in well with all the other endpoints? But there's another layer which is really, really fundamental, which then is, if I can have an idea which passes all these tests, so I've got the idea, I can implement it, it fits well with the rest of the design, then I have to ask the question, could I imagine teaching this design, this idea, to a 10-year-old child? And 9 times out of 10, the answer is no. And so then I stop. And so, and I repeat and iterate. So I have many ideas which are sort of floating around in space right now in my head, which I'd like to build, but I haven't yet figured out how to make it simple enough for a 10-year-old child.
So can you give an idea of something you would want to include, but got deleted because you thought there's just no way I can explain this to a child?
Yeah, so that an idea at the moment which I really want to have, which is a musical idea, which is called side chaining. So if I take
what is that?
So this is a standard technique used in dance music, where if you have, for example, the kick drum banging, poof, 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 what tends to happen is when the kick drum kicks in, the rest of the music the volume is reduced just for the duration of the kick drum and then brought back up again. So what that does is it gives space in the music, in the mix, for the kick drum to happen, and something called a compressor is used for this. It's all very technical. But I really like, it's a really nice sound, it's really a sound that children are very used to hearing, and so it'd be great to be able to have a very simple way of just having that effect. But the current way that Sonic Pi implements effects is using closures, and there's a very clear nesting of closures. I can have a closure inside of a closure inside of a closure, so I can essentially chain effects very easily by having an effect inside of an effect inside of an effect, like an onion ring. But the idea of sidechaining requires you to have two simultaneously. And I haven't got a simple way of creating a syntax yet that's going to allow me to do that. So I could easily build it, but I couldn't imagine teaching a 10-year-old child how to essentially create a lambda function and pass it in as an argument to another function. Like, it's already too much.
Yeah. So how do you obtain knowledge about what 10-year-old kids understand? Because you say, I cannot imagine how to do it. Have you had features that you tested with children and that you removed later because it just didn't work with them?
Actually, no. So what happened was that the first version of Sonic Pi took me 2 weeks to build because we had a 3-month period to do the whole project. And then after those 2 weeks, I was in classrooms observing children using the system. And so from day one, really, it was built within classrooms, with teachers, with observation of children. And so all of the features grew initially for the first year and a half through direct observation of children on a multitude of different projects all over the UK. And so I really can say with assertion that during that period that every feature I built, the kids could use, because I was very careful to slowly build the features and watch their observation. Since then, there's been a focus on the musical aspects as much as the computer science teaching aspects, but I've used my knowledge of my observations of the children and then also used my relationships with teachers for discussions to figure out, if I did this, do you think that would be okay? And so there's a lot of discussion, a lot of discourse, a lot of reflection that goes into this, the process.
Are there features that you regret?
That's a good question. Yes, and I removed them. And so I have no problem with backwards compatibility.
Which one? And why?
So let me think about this. So for example, I initially implemented the randomization system using... So Ruby has a rand function like every program language, and I used that to great effect to allow people to be able to say, choose a random note from the pentatonic scale. And that was a great way of easily making compositions without having to compose. Because you can just say, choose me a bunch of notes. If I don't like them, choose another bunch of notes until I do like them. And that was great. But what it didn't really allow was things like being able to reproduce my performances across runs of the software. Or if I sent my code to somebody else, I want them to hear the same piece of music.
Because it would do the randomization again and you would get a different random note.
Differently for every time, yeah. And there was also things I figured out what I wanted to do. If I had a line of code in an iteration that called a random value, and that produced me my baseline. And then I say I wanted to randomize another aspect of the music, say it's timbre. If I then called that rand, then I'm calling it twice, which then interferes with the first set of rands. So now I get a different baseline. So I wanted to be able to undo calls to rand, which is like taking a card from a deck and then putting it back on again. So when I take the next card, it's the same one. And so typical programming languages don't really support undoing the side effect of calling a random value off a random function. And so I then had to then go back and re-implement Sonic Pi's randomization system using a much simpler a sort of less random approach, as it were, but random enough to allow me to have these kind of features, which it has now. But what that meant is that earlier compositions, which use randomization, now no longer work because the randomization system has changed.
Oh, how did you solve that?
Well, you can't. Yeah, mainly because my new randomization system isn't infinitely random. I actually tried to do a depth search of trying to find that composition in the new random system, and I couldn't find it, so I had to change the composition.
So you just communicated to users, sorry people, we've changed something, and your stored song might sound very different in this new version of Sonic Pi.
Yes, exactly. And every version of the Sonic Pi has a full release list, and there's a full list of changes that are incompatible. And I mean, this was a big change. There aren't that many of them which are as broad impacting as this. But at the time, there weren't that many people that I could observe using this feature anyway, so I don't think there was a radical... Certainly wasn't any lashback in the community. No one really even mentioned it. So I don't think there was that much impact. Obviously, as the software grows, my ability to make those changes is going to diminish. But I'm still in favour of breaking backwards compatibility where it makes sense in terms of making it simpler for new users who are going to join the community.
So talking a bit about the user base, because you already hinted at it a little bit, you say, well, I didn't see people use this feature anyway. How big is the user base, and how do you know what people are using?
So I have a few ways of observing that. Obviously, you can never know this. I know that Sonic Pi calls home to ask if there's an update. So I can see how many people are asking for updates. So these are people using Sonic Pi that haven't opted out from that feature. You can turn that off if you want to remain anonymous. And there are about 300,000 users who have done that. Then there's also the Twitter feed, which I search for people mentioning Sonic Pi on Twitter. And so every day there's a number of people who tweet about it, so I get to see the community that way. And there's also the mailing list as well, where people are discussing ideas. So these are sort of the three main points that I can observe the community. Yeah, so does that make any sense?
And do you have any idea what the biggest part of the community is? Is it children playing at home? Is it in school settings? Are it professional musicians?
I think that the largest set of people I've observed are workshops and lessons in schools. But actually less on lessons, more on workshops. So people giving impact workshops or introductory workshops or exploratory workshops on programming. I see a lot of activity all around the world of that kind. I see some activity which is growing in schools, but that's a really tough problem, which we can discuss if you want to. There are many barriers to that already that we have to find ways through. And in terms of the professional people, obviously, I don't think there are any professional live coders using Sonic Pi at the moment, or any professional musicians yet. But there are a larger and growing number of people who are using it to have musical outputs, and the kind of music they're making is increasingly more exciting to me to hear. When people start playing Sonic Pi, just like when people start playing the piano, it all sounds fairly similar. But as people are creating their own styles, that's really exciting to watch.
Oh, that's nice. So does that impact the language? If you hear a piece of music that someone created, do you think it would be even better if it also had that musical feature? And does that impact the language?
Absolutely. And also, when I observe people doing things which I don't feel are idiomatic, I then haven't somehow communicated what idiomatic means.
Yeah.
And so then I think about how do I try and coerce these people in the future to follow the idiomatic path that I believe in.
Do you mean idiomatic in terms of how they write the source code, or idiomatic in terms of how the music sounds?
Oh, absolutely the source code. I don't want to make any impact at all on what music people want to make, because I believe that's their expression of their own personal ideas, and that's not for me to have any filter over. However, there are a number of times where I know that if someone had written their source code slightly differently, it would have given them more freedom to be able to move from that. Because another way to think about live coding music is it's a bit like exploring driving around an unknown territory, or walking around an unknown territory. And there are certain places which are like dead ends, and there are certain places which give you 5 different directions you can go in. And I know that there are certain forms of the code are more like dead ends, and they are like points of varied movement.
Can you give a concrete example? Because it's
yes,
a bit abstract.
Sorry. It's all very abstract, and until you really get involved in these things, it's very hard to see this. But one clear thing is the manipulation and management of time. Sonic Pi does really strange things with time. It plays around with it in new and exciting ways. That allows you to then work with lots of things which manipulate time at the same time. Again, I'm still working in a very abstract way. So let's think of a concrete example. So if we have an effect, so I can make a sound which makes a noise, blah, beautiful sound, and then I can apply an effect to it. So I can add reverb to it, or I can add distortion to it, and that's with electrical closure. Or I can slice it, so that means that I've got someone on the volume knob turning it on or off. So instead of going blah, it's blah, 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 blah. So that's on, or I can do it quickly, blah, 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 or slowly, blah, blah, blah. And so the rate of the on-off of the slicer is a temporal, it has time. Now, if I also have a beat, a sample, a pre-recorded sample that has a rhythm into it, and I play that rhythm at the same time I'm playing my slicing of my sound, if the slicing isn't in the same tempo as the beat, that might sound incorrect to some ears. It's in certain contexts. Sometimes it might be exactly what you want, but in other cases it might not. And so then the question is, well, how do I make sure that they actually sound good together? And so there are certain constructs syntactically you can use which can make that much easier to make these the same time than others. And it can also allow you to change the whole BPM, the whole speed of the entire track. And without having to change the slicer speed, having to change the sample speed, you're changing them both simultaneously, rather than having to go and manually control them both independently.
So the syntax allows users to say something like align these two pieces of things, and then you don't have to think about it yourself. The language encourages you to align it, and if you want to have it not aligned, then it's harder to do in the syntax.
Exactly. Whereas the non-idiomatic way is to not have them aligned, and then suddenly it's much harder to then go and align them. You have to modify a lot more code. Or people ask, "Oh, why does the sound not very good?" And so this approach is I've solved it, or I haven't solved it, but I try and solve it by more clearly in the documentation explaining where you should or shouldn't do this. Or if people tweet, for example, a little melody, I'll write them back and saying, "That's great, but you might want to consider using this approach," and then link to the documentation so that they're aware that there are other ways of doing what they do.
So it's very interesting that you do that on Twitter, but this could be something that would be in your IDE as well, where you would suggest refactoring, saying, hey, this is not the way you do it. Is this something you're thinking about?
Absolutely. There's lots and lots and lots of things I'm thinking of, but it's just the matter of time and effort. So if there's anyone listening who would love to get involved, then there's tons and tons of things to work on. Yeah, and I think making the IDE communicate more things to the user is clearly only a good thing. So I want to communicate not just what refactorings are possible or what reconfigurations are possible. I also want to be able to enable live refactorings on an AST basis. So I want to consider moving away from text representation to more of an AST representation of the code, like Scratch does, for example, and allow edits to be tree transformations. That kind of thing would be really powerful. But I also want the code itself to come alive as it's executing. So the moment you write some code, you press run, and then you hear the music. There's a little log which describes the process that's going through, but once you get to a certain level of complexity, that log just flies by. Like if you've got a popular website and you look at the Apache logs, it's just flying by. You can't really do anything meaningful with it as a human looking at the logs. And so, are there ways to animate the text that sort of in time with the music that allow me to say, well, this is the live loop which is going really fast, or this is going slowly, or this is where this is the source of this sound is here. Yeah,
because there are some languages for programming languages for children, like Lego Mindstorms, for example, that highlights the blocks that are being executed.
Precisely, exactly.
It's often useful to
Dave Griffiths, for example, does this with his block language, which is a Lisp, which uses 3D graphics. It's a beautiful thing to watch as a performance, but it really does clearly communicate what's happening in terms of the execution process.
Yeah, and talking about code quality, there's of course, apart from refactoring, also testing. And normally you have tests for your source code, and if you run it and you make a change, then a test will break. I understand that with Sonic Pi you can just listen to the source code, but can you imagine a testing environment as well? If you do something really funky and your sound changes a lot, is the only way for the listener to listen?
That's a very good question. I mean, obviously, I've thought about this in terms of the development of the software itself, but I never think about testing as when I'm performing, ever. Not to say it doesn't have any value, it just hasn't ever been something that I've seen immediate value in. Mainly because the liveness of the situation is kind of a testing environment already. People already talk about REPL-driven development as a way of reproducing much of the perceived benefits of test-driven development. And you can see some similarities there. I'm not drawing any sides, but you can sort of see it. And so when you're doing live performing, live programming, live coding, the time for you to observe what happened is so short that it's very easy then to go back and forth and to treat your code like clay and not think of it as a structure that needs to be tested. It's just a form that has the right form in the moment or doesn't. If it doesn't have the right form, then you can just tweak it until it does. So I can't remember who actually told me this analogy, but it's a really important one right now, which is if you imagine the goal to be hitting a target in a remote distance, one approach would be to get a bow and arrow of the same kind of quality in the Olympics with all of the eyesights and the tunings and the weights and really and then you be more like testing, because what you're doing is you're saying, I'm going to take into account the wind flow, and I'm going to take into account the distance and the weight of the arrow, and maybe I'm going to do some mathematical calculations to make sure that I'm going to guarantee to get that far, and you can spend a lot of time setting the bow and arrow up and then firing it, hoping it's going to hit the target. Or you can just get a hose, start spraying it randomly, and then you need to ask the question, am I going further away or closer to the target? Right? And then you just keep going closer and closer, closer, and then you hit it. And so live programming to me is much more that approach. It's much more ad hoc, but because you have this liveness, you don't have to do all this beforehand, setting up structure and testing and creating mathematical models to make sure you're going to be accurate, because you have the ability to change it.
So let's talk about code as performance art a little bit more, because that's where we're going anyway. There are even parties for this, right? I understood there's something called an algo-rave party where people go to listen to people performing with source code.
Absolutely. There's something called the algo-rave movement, which was started by Alex McLean and Nicholas Collins. And apparently they were on a car journey to listening to happy hardcore or something. And they thought, oh, this great term algo-rave came to their head. And what that turned into is this large movement of individual people creating parties where the main instrument is code. And a lot of that's live coding, so people modifying the code, improvising live, but some of it's people preparing compositions beforehand as well and going and hitting execute, which may contain machine learning or it may contain randomization systems. But predominantly the idea is that you have algorithms making the music, which is the algo of the algo rave. And the rave part is pointing back towards the rave movement of parties where dance music was a really big and important thing. Mainly because I think it's actually very easy, typically, relatively, to make dance music from code than it is to make other music, because of the repetition is something that code can do quite clearly with loops and iteration. And it's great to see a range of people from all sorts of backgrounds and disciplines, both from the programming backgrounds, academic backgrounds, musical backgrounds, all making music together for other people to listen to. And to see the range of languages and tools in use is a beautiful thing.
So often at these parties, people aren't just looking at the performer, but the source code is also on the screen.
Absolutely, yes.
Which is, that's very cool.
But it's like saying, to me, it's like, imagine going to a guitar gig, a guitarist who then hides their guitar behind a curtain. Like, you'd question that. So to me, projecting the source code is just like showing people your guitar. It's just an obvious thing to do.
Yeah, no, if you say it like that, it makes total sense. But it's still strange that you go to a party to read source code.
Most musicians don't tend to communicate to the audience the process in which they're making the music live. And I think that live coding and projecting the source code offers the performer an opportunity to demonstrate the process they're making, that then can include the audience.
So does that impact the language again? Because you want to have a readable syntax so people can understand what you're doing.
I think that if you ask a number of people in the live coding community, people who perform these things, you'll hear a variety of answers to that question. So I can only really answer from my perspective. And for me, I think it's very, 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 very important that the audience, if they want to, not all of the audience will want to, can perceive some of what's going on in terms of the code. So there's a number of ways to achieve that. One is to make sure the language is more easily understood. And so one of the benefits of working in classrooms is I've made sure that my language is understood by 10-year-olds, but that also turned out to be making it fairly understandable to audiences who've never seen the system before. But also, it's not just about making the language simple, it's also about making the presentation simple. So one of the things I try and do is to work with large fonts, so the code is large on the screen, so that means I have to reduce the amount of sort of algorithmic complexity in terms of syntax, which is on screen. Obviously, I'm allowed to use libraries underneath the scene, so I'm able to maintain some level of complexity in terms of the output, but in terms of the interaction of the system, I'm trying to make that as simple and readable as possible. And my observations have been that when for example, I performed in a gig in America, when I made the code really simple, so for example, I made sections of the performance so simple in terms of code that it was 1 or 2 lines, that I observed in the audience, they just stopped and stared. And so when I made it simple enough for the audience to read, they could actually read it, and they did read it. And then when I communicated to them through comments, so I could write a comment in the source code, the audience would laugh and engage and cheer based off what I was saying. So people were actually reading the source code to allow me to then to communicate with them. So I really believe that's for me, it's a very, very important thing.
So do you want something in the language or in the IDE to very quickly change? Because if you're performing and it sounds bad, you have to be very reactive. Yes. What specific features do you have for that?
So I have, let me think of some examples. So I have a system called a live loop, which is kind of an inversion of something called temporal recursion created by Andrew Sorensen.
Not everyone might be familiar with that. Could you please explain?
Exactly. So I think the live loop is actually easier to explain. That's why I created it. But I wanted to make sure that the provenance of it is clear to the audience. The idea of the live loop is that it's just a loop. You say loop around some code. But the live loop has one important difference. It has a name. So I call my live loop foo or bar or baz. And the way to think about this is like it's a performer. Right? So Sam's performing, Sally's performing. And so that in my band, I can have multiple members, but they all have to have unique names. So I'm able to say, Sam, get the bass going. John, you do the drums. Sally, can you do the cymbals? And in that sense, I already have introduced one strange concept to a lot of programmers, is my loops, my live loops, have a notion of concurrency already. So you can have multiple live loops running at the same time. So they're more like agents or something, or actors in an Erlang context. And then in addition, the behavior of the live loop is something you can modify on the fly too. So you can say, I'd like my live loop to do this, like play a bass drum, bang, bang, bang. And then after a while, I'll say, well, actually, no more bass drum, can you play a cymbal? So I change its definition, and next time around the live loop, it plays the cymbal. And so I'm able then to modify what's going on the fly and to be able to change it. And so in terms of the features, these features are really important, and also time as well. The live loop manages its own time so that it stays exactly on time, depending on how you describe the delays between drums hits. So if I say, I want you to play a drum, wait for half a second, play a drum. So in Sonic Pi, that would be sample, drum, sleep for half a second. I would have a live loop, foo, do, sample, drum, sleep for half a second, end. And that will play my drum. If I then change the sample to cymbal, the next time around the live loop, it would play the cymbal. Or if I change the sleep time to be longer, it would slow down the live loop or speed up the live loop.
So do you do that change within the live loop?
Yes. And so if for programmers listening at home, the implementation is I gave a talk at Strange Loop a couple of years ago, if you can look online.
We can add a link to
that. Absolutely, which explains all this in detail. But essentially, it's just each live loop is a thread which executes, which has a body which is an infinite loop, which calls a function you can redefine. And so by redefining the function that implements the live loop, you're able to change its behavior next time it dereferences that function and calls it. And so in terms of how do I deal with mistakes being made, well, one mistake to be made is that, so if I have 4 live loops going, for example, and when I press run, they all start at the same time, because I have this lovely notion of time, which is inherited by all the threads. And again, I can go into detail about this if you want to, but just to try and keep it at this level, it's just, when I press run, everything starts in time. If I put a mistake in one of the live loops, if I put a typo in there, obviously I get a runtime error at this point. That live loop will die, but the other live loops will still be running. So if I'm performing, a good tip is to have multiple live loops. so that when you make a mistake in one, and you will make mistakes, only that one live loop suffers and the rest are still going.
At least there's not a silence then in
Precisely.
the performance.
Yeah. And you can sort of pretend that was what you wanted to do. Then the goal then is to fix the mistake and then get the live loop running again. That's easy, but also to get it running again in time with everything else. And so when you press the run button to start the code again, it will start that live loop from when you press the run button. So you'd have to somehow manually hit run at just the right time to get that live loop to start in synchronization with all the others.
You can get it to sync up easily.
So again, this is where I build a system called sync, which allows me to write with syntax to say this live loop syncs with this other live loop, so then it will wait for the live loop to go around before it starts the next one. So with syntax, I can then fix the problem of having to worry about timing the live loops together. And that's, again, that was quite a complicated system to build, but it's actually very simple to use, and this is one of the goals. Simple in terms of interface doesn't always mean simple in terms of implementation or design. Actually, it doesn't.
It could be a contrast.
Correlate, exactly.
Yeah, so performance does indeed influence the syntax or the things you can do.
Precisely, because also you need to think about, if I'm hearing the music and it sounds nice, I imagine where the music could go to, I want to try and make sure that the amount of syntax changes I have to write to make that change isn't too great. I don't have to introduce accidental complexity in terms of describing that difference. I just want to describe purely that difference as clearly as possible. So if we talk about when you build a design, there's some level of essential complexity that you have to have for that design to even work. But then whatever material you're using to build that design adds some extra bit of complexity that's just annoying, but you just have to do it.
Yeah.
And the amount of that extra complexity is also a function of the design as well. Worse designs will require more accidental complexity. And so trying to reduce that accidental complexity is a really key in terms of reducing the amount of syntax you have to write or modify, or things you have to think about when you're performing. And you want to try and make sure you're just thinking about the music and not thinking about lots of other things that are just annoying.
Yeah, I think that from a language design perspective, that's really very interesting. Because all too often, if you design a language or even an API, you say, well, the user just has to do this 3 calls, and then they have access to our entire library.
So the solution is
you don't have that luxury.
Training. Yeah. You can't train people. Another example would be if I write this function and this function, the system breaks, for example, because there's a bug in it. One solution in a business context is to train the users never to do that. Yeah, and that's a perfectly fine, affordable solution if you have the ability to control your users. If your users are school children, you can't train them to not do that. Of course they're going to do that. And so you have to make sure the system is resilient enough to manage and deal with that. And you want to make it as simple as possible for those things to be achievable.
So it's interesting because you keep comparing Sonic Pi to a musical instrument because it's a means of performance, which I totally see. However, there's a variety of musical instruments and they can play together, whereas Sonic Pi is one language to make all the music. Do you envision you would get specialized versions of Sonic Pi, that there would be an evolution into different forms?
Absolutely. I just haven't got to the stage of maturity in the project that allows, for example, the equivalent of Java jars or Ruby gems for people to add extensions. That's something that I'm working on that will be there at some point to then allow people to modify. The way I see it at the moment is that Sonic Pi is a very good base set of semantics, which manages timing, it manages effects chains, manages modification of code, and does it in a really robust way. And so, to me, that they're the sort of semantics to build things on top of. And so I can totally imagine people building their own abstractions on top of mine, which gives them different affordances, and then sharing those abstractions with others, which then would create new kinds of instruments or new ways of more effectively creating certain kinds of music, if that makes any sense. I can imagine functions that people might write, which would give them some parameters, which would have great control in certain kinds of contexts of music making. And if people share those functions with others, then that's a great way of collaborating to create new kinds of adapted instruments in many ways. There's also the idea of synchronizing temporally multiple computers together. That's something that live coders have been doing for a long time. But again, this is something which is technically feasible and a bit fiddly, but it's not something I can imagine a 10-year-old child doing yet. So we need to make something that's as simple as Apple just released their new AirPod things.
Yeah.
And one of their goals was you open up the box, you press a button, and you've got listening to music. And although there's all these complicated protocols going on behind the scenes, from a user perspective, you open a box that you've just bought, you press a button on your iPhone, and you can listen to music. That's the level of simplicity we need to have for it to be something that teachers are prepared to pick up in the classroom, because often teachers don't want to be doing network synchronization, right? That's something they don't have the training or knowledge to be able to do. So these things need to be in place first before we are able to do effective synchronization, which would then lead to things like Sonic Pi orchestras, or being able to have Sonic Pi talking to any of the other fabulous live coding systems that exist.
So, how do musicians feel about this? Do they see Sonic Pi as a new musical instrument, or have there been composers that have created pieces with a normal traditional instrument and Sonic Pi? How will it change music? Get it?
Very good question. I could spend probably the rest of this 2 hours describing this, at least. I've had mixed responses. So I've had conversations with eminent musical educators who have a very traditional view of music. And those conversations have often been almost frictionful or even aggressive in a mild manner of, this is not music, this is music, and then point to sort of Western score, which is only one vision of music. There's much more to music than just Western notation and dots and stave. But still, they would ask the question, and so there would then be, I would say, I believe this is actually a new notation for music, and I think it's a really interesting direction to go. And then they would say, can you do this? And they would say some fancy Italian word, pianissimo, forte, whatever it is. And I'd say to them, I have no idea what you've just said. Could you explain it to me in simple terms? They go, oh, okay. And they would write this down in simple terms. And they say, oh, okay. And then I will be able to write the code and I'll be able to do that. And then they would go, oh, but can it do? And this would happen for about 5 or 6 iterations. And still they would be unconvinced it was music. So there's that kind of strange traditionalist view that's going to struggle to be changed, which is very entrenched in the music world. But then there are musicians who are using it. I mean, I have seen operas being written with Sonic Pi, people have talked about. I have seen, what else have I seen? I've seen school children doing assembly performances to the rest of the school, like 10-year-old children who have taught themselves how to do this thing, who have been practicing on the internet using FaceTime. So that's a fabulous thing to see. Of course, I've seen the algorithms you're talking about, people performing with Sonic Pi. So that it is entirely possible. And then there are music magazines and for example, the Rolling Stone, they covered a Sonic Pi gig and said that it's, for them, they saw it as a really important future for music. They said that the performance even transcended the present. So I think that,
wow.
that when traditional magazines like that are understand, and they also said that the code made the music making process more transparent. And they were drawing direct correlation to synthesizers, which they said were much more confusing and complicated, which I thought was a very interesting statement to make. So for even a music magazine to get that code could actually represent a simpler way of making music, a more approachable way of making music, was a fabulous result.
Yeah, that's very impressive, because if people use a synthesizer, you can't really see what knobs they're turning, and your knobs are syntax, so
precisely,
it's easy to follow along. That's cool.
Yes. And also, synthesizers are expensive. They're really expensive to set up and buy. There's this Eurorack thing, which are fabulous, but each module is hundreds and hundreds of euros.
And Sonic Pi is free, right? Free. And open source. Let's mention that, because it's just wonderful.
And it doesn't need a fabulous MacBook Pro. It runs on a Raspberry Pi.
So, talking about programming for children, because you started it at the Raspberry Pi to make it very accessible, why is it important for children to learn programming?
It's a very good question, and I think that when you hear answers, they're often related directly to business and the shortage of programmers in the world. And although I have some appreciation of that as a problem, I don't think that the lack of workforce should really be the thing which directs what people are educated in, to be honest. I think that is there a lack of footballers in the world? Should we emphasize sports teaching? I mean, are we teaching mathematics to create more professional mathematicians? Are we teaching English to create more people who write or read? I don't think this is the case. So although I think that I sympathise with the lack of programmers, and I think it'd be great to have more programmers, I don't think that should be the reason people learn to program. To me, what I think is important is to see that the world we live in is ever increasingly affected by programming. That programming is affecting all industries, it's affecting all our creative pursuits, and that's not a bad thing, it's a fabulous thing. That if we learn how to program, it gives us more power as humans to express ourselves in new ways. And to me, that's the main motivation to learn to program. Just like we learn to read or write, not to be a professional reader or to be a professional writer, we learn to read or write because it allows us to communicate our thoughts and ideas, both personally and professionally. I believe that programming has similar roles to play in society.
So what other forms of expression do you imagine children can do with source code, apart from obviously music that we talked about a lot in this podcast?
So this is an important thing to talk about, because when we talk about programming, we talk about it directly for industry. I wonder how many of these podcasts people listen to have been industry focused. I mean, and how much of the programming world in the future is going to be purely industry focused? I think we already live in a very skewed world. And I think that it's not just interesting to talk about what expressive forms code could allow today. It's also important to think about what it could allow tomorrow and where could it take us. And so already today there are many pursuits you could take, like music, like art. There's processing, for example, lets you do beautiful pictures. There's lots of ways to use programming to build things that allow you to robots, or things that can fly, or things that flash and talk, or you can imagine something like a magician, and you can use programming if it's useful to make that thing a reality. So there's many ways we can use programming to help us to communicate and build our ideas and to share them and to express ourselves. And I really think we should, as a society in general, but also as a community of programmers, we should be celebrating all of the non-industry pursuits we could take with programming and placing a huger priority on that, because it's the non-industry pursuits which are going to have the largest change in the world, I think, than the industry ones.
That's an interesting and a very good thought, and I'm really curious to see what all the children that you've been teaching and other people have been teaching will come up with in forms of self-expression with code. So we're in the UK right now, and the UK is one of the countries that has achieved the most in this, because in the UK, programming at schools has been mandatory for 2 school years.
Yes.
So what is your take on that? Are they succeeding? Is it a good thing? How is it going?
I think it's a fabulous thing that the peer group that was created, Computing at School, headed by Simon Peyton Jones and others, was listened to by the government and was turned into a curriculum. That's a fabulous thing. And now we are able to have a conversation which is along the lines of teaching people office skills like PowerPoint and spreadsheets isn't just the most important thing about programming. It's also important to be able to build the next PowerPoint and the next spreadsheet. And that conversation is a real conversation that people are having, which is fabulous. It's not to say that learning how to use a computer as an office tool isn't important, and it should remain to be important, but there's another deeper set of skills that really should be understood to some level by the majority of people. And so that for me, this is a really important thing. The problem is, though, that although the government, we're talking politics now, added the curriculum, it had provided, and still to this day hasn't provided any financial support for any change to happen. So there's no money to be paying for teachers to retrain, because a lot of teachers are really struggling, because the teachers were teaching how to do Office or how to design a nice logo as part of the IT class, and now having to teach algorithms. And that's a large jump to make for a lot of teachers. And some of those teachers are very happy to self-learn, which is fabulous, but others are going to really struggle and they really need support and help. And so it's fabulous that charities like the Raspberry Pi Foundation offer free training. They have something called Pi Academy, which teachers can sign up to, which is a 2-day course, which sort of bump starts them into having, again, not to teach them everything, but to make them not scared of programming is really the main goal, and to give them access to a community and to allow them to see that programming isn't actually that hard. It's just a bit frustrating and different, and that a large part of the thing is that you don't need to have all the answers. You just need to be able to know who to ask the questions to, which I think every professional knows this. Every professional knows that you can't know all libraries, but you know how to learn the libraries that you need to do your work.
Yeah, because teachers are used to having all the answers. They know everything in elementary school about language, about mathematics, and every question a kid can have, they can answer. But that's something they have to let go in terms of
And I think that's
programming.
something that's changing in education in general. Like the source of knowledge is the internet now, not the teacher. The teacher really should be, in my opinion, more a facilitator of learning rather than the deliverer of knowledge. And part of being a facilitator is recognising that there will be individuals in the class who know more than you. Or it's also accepting that you don't know the answer to something, but you can go and find it out, and next week you can come back with the answer. And that's not a problem. It shouldn't be perceived as being a problem. Saying I don't know something isn't a sign of weakness. To me, it's a sign of strength. To me, a real sign of weakness is saying I don't want to know that thing. That's a real problem. Or I don't get that and I never will get that. That should be the thing which is attacked and challenged. What really should be encouraged is, I don't know that, but I'm going to learn it. I'm really excited to know what that might be.
Learning is hard for everyone, of course. Does Sonic Pi have specific resources for teachers? If there are people listening that are a teacher or know a teacher,
there's four main resources at the moment for Sonic Pi. There's the tutorial, which is built into the application itself, which has been translated to multiple languages, which is the best way to get started. It's written assumes you know nothing about music or anything about code either. So if you know a little bit about either, you'll be able to fly through it. And if you don't, you should be able to work through it at a good pace. And my promise to the listeners at home is if you're reading through the tutorial and something doesn't make sense, that's my problem, not yours. And if you can let me know where there's some difficulties, then I will fix them for the next people. So there's a tutorial. There's also I've written a book, which is freely available as well, which has lots of ideas in terms of sort of, it was written as a series of chapters for the Magpie magazine for the Raspberry Pi. And so that's another sort of resource as well. But then for teachers, the Raspberry Pi website has a specific computer science curriculum for introductory computing that we've written, myself and Carrie Ann Philbin, who was a teacher I collaborated with. And that's freely available, open Creative Commons license, and that's on the Raspberry Pi website. In fact, I think they have two resources similar to that.
We'll make sure we'll link to all of the things you promised.
And then there's a project which I worked on, which was Nesta funded, Digital R&D for the Arts actually, which was focusing on not computer science but music lessons. And so we have starts of a music curriculum for schools available for people to read as well. That's on sonicpiliveencoding.com.
Awesome. Well, I think we covered most of what Sonic Pi is. It's a language for performing with source code that's inclusive of young children. Is there anything you want to add that I forgot?
I could talk for hours, but I don't have hours. I'd like to say thank you to everyone who supported me for the work I'm doing, and that it's important that I mention that although we've talked at great length about Sonic Pi and live coding, that Sonic Pi is one of many live coding systems. And there's a whole range of different systems that people can play with. And if people are already programmers and they already have their favourite language, then you'll likely find a live coding system in your language that you can play with. For example, if you're a Haskell programmer, there's Tidal. If you're a Ruby programmer, there's other things than Sonic Pi that people have written. People have written their own direct, I can't remember their head, maybe we'll find some links, which actually do the synthesis in Ruby itself. There's Lua environments, there's JavaScript environments, there's Python environments. So go and find an environment for your language. But if you're interested in a really simple way to get started that tries its best to make sure every aspect of the design is similar for a 10-year-old child, then there's not many other languages that try and do that. Sonic Pi will fit those goals, hopefully. And if it doesn't, let me know and I'll fix it.
Thanks. So there's just no excuse for any programmer out there to become a musician with a range of live programming tools out there.
Precisely, yeah. And what I would like people to do, if they're professional programmers, is to think about how they can use their skills as a professional programmer, not just for business. How can you change the world in ways which aren't necessarily directly correlated to making money? Because are all the good things in the world that we do directly correlated to money? I don't think they are. And so should programming be the same? I don't think it should. I think we should be thinking about how we can use our amazing, fabulous skills that we all have, that most people don't yet have, to change the world for the good that we see. And part of that is building new things, and also part of that is educate what we know about programming to people who don't know about it, so that they themselves could do the same things we can do too.
I think that's a fantastic closing statement. Thanks a lot, Sam.
Thank you very much.
Getting software to your users quickly and reliably is the most important part of being a software engineer. SnapCI's cloud-based continuous integration and continuous deployment tool lets you set up in minutes with your GitHub account, and within a few clicks will have your first pipeline running. Discover and fix your bugs quickly before pushing to production by setting up stages from simple ones to complex that run automatically when you push your changes. Need more speed? Run tests in parallel with expanded workers and get your feedback fast. Deploy to Heroku, AWS, and more. We even integrate with Slack to give you updates on your builds. Go to snap.ci/softwareradio and build, test, and deploy free for 30 days. SnapCI embodies the lessons that ThoughtWorks has learned from 20 years of software deployment, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareradio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.